So before we talked about the lobes of the lungs, we talked about these alveoli, and basically these alveolar duct. The ducts run into the alveolar sacs, and the alveolar sacs contain the alveoli. So the alveolar duct is a tube that is composed of the smooth muscle and connective tissue, and it opens into this cluster of alveoli. The alveolus is kind of just like a small grape-like sac, and they're attached to these alveolar ducts. The alveolar sac is a cluster of a lot of alveoli, so up to 300 million in the lungs in general, so there's a very large number of them, and they're about 200 micrometers in diameter, so very small, but they have elastic walls that allow them to stretch when they're taking in air, and this greatly increases their surface area that is available for gas exchange. So these alveoli are connected to their neighbors via these alveolar pores, and this helps maintain equal air pressure throughout the alveoli and the lung. So these are the main sites of gas exchange, your alveoli. Looking closely at the vasculature that surrounds the alveoli, we can see the deoxygenated blood from the pulmonary arteries, or arterial smaller arteries, dropping off carbon dioxide and picking up oxygen based on concentration gradients. There's more oxygen in the alveoli than in the deoxygenated blood of the pulmonary arterial, so it diffuses into the capillary bed, supplying the alveoli, while carbon dioxide does the opposite based on its concentration gradient. So recall, the capillary bed is made up of simple squamous epithelia, and it just so happens the alveoli is as well. So this allows for ease of diffusion down its concentration gradient for both oxygen and carbon dioxide. So before we start getting into the nitty-gritty of breathing, we have to understand the different pleura of the lungs. So each lung is enclosed within a cavity that is surrounded by the pleura, which consists of two layers. Our visceral pleura is the layer that is superficial to the lungs. So it's right next to the lungs, directly over the lungs. And the parietal pleura, is the lining or the pleura that is the outer layer, and it connects the lungs to the thoracic wall. Okay, and also the diaphragm as well. So down here, so thoracic wall and the diaphragm. The pleural cavity is literally just this space between the visceral pleura and the parietal pleura. And so these pleura perform two major functions. They produce pleural fluid in between each other, so this pleural cavity is filled with this pleural fluid, and they also separate the major organs. So the pleural fluid acts to lubricate surfaces, and so it reduces the friction between the two layers, and it prevents trauma while breathing. So the ease of breathing basically creates surface tension that helps maintain the position of the lungs against the thoracic wall. So it makes sure there's a constant pressure. This adhesive characteristic of the pleural fluid causes the lungs to enlarge when the thoracic wall expands during ventilation, and this allows the lungs to fill up with air. The pleura also create a division between the major organs that prevents interference due to the movement of the organs, while also preventing the spread of infection if there was an infection elsewhere. So pulmonary ventilation is referring to the movement of air into and out of the lungs. Air is always going to be moving from an area of higher pressure to an area of lower pressure, moving down its gradient from a high pressure to low pressure. So pressure is inversely related to volume. This is called Boyle's law. When we change the volume, we change the pressure of the air inside, and this causes airflow. So if you look at a closed off container with a fixed amount of air particles in it, they're going to be bouncing around, moving around, causing heat and thus pressure, and this is the basis of pressure. They're all bouncing around, there's gas in here. Well, if we put a piston on the end and we move it up, we're increasing the volume, we're increasing the amount of space that those same amount of gas particles can move, but there's less pressure on them because they're not bouncing and running into each other and bouncing off everything, hitting each other. So there's less pressure because there's more room for them to bounce off and lesser likelihood of them hitting each other. But if we move this piston down, sorry, my mouse keeps disappearing. If we move this piston down, we're decreasing the volume, the space that they have to operate, which increases the likelihood that they're all going to run into each other, which means that we're increasing the pressure. So as this diagram shows, as volume increases, the pressure decreases. And as volume decreases, our pressure increases. And so that's exactly what these equations down here are saying. P1 V1 equals P2 V2. You can get all bogged down with those equations if you want to, but you don't need to. Just understand that pressure and volume are inversely related. Okay? And this is the basis of breathing. So pulmonary ventilation is dependent on 3 different types of pressure. We have atmospheric pressure, intraalveolar pressure, and intrapleural pressure. Atmospheric pressure is the amount of force that is exerted by gases in the air surrounding any given surface, such as the body. Typically, for respiration, other pressure values are going to be discussed in relation or in reference to this atmospheric pressure. So therefore, negative pressure is pressure that is lower than the atmospheric pressure, whereas positive pressure is pressure that is greater than the atmospheric pressure. And a pressure that is equal to the atmospheric pressure is expressed as 0. So that's exactly what we see here. Atmospheric pressure is just atmospheric pressure. Intraalveolar pressure, also shown as intrapulmonary pressure. I'll probably refer to it as intrapulmonary pressure typically. This intrapulmonary pressure is 0, which means it's equal to the atmospheric pressure, while our intrapleural pressure is negative, which means it is less than the atmospheric pressure, and therefore the intrapulmonary pressure as well. Intrapulmonary pressure is the pressure of the air within the alveoli, so literally the inside of the lungs. So that's why it's called intrapulmonary. It's within the lungs, pulmonary being lungs, intra meaning within. That's also why it's called intraalveolar pressure, because it's literally inside the alveoli that we just discussed the anatomy of. So it can go either way. It's just very specific when it says intraalveolar, but the old texts and literature will usually use intrapulmonary. So this intrapulmonary pressure is the pressure exerted within the lungs. Intrapleural pressure is the pressure of the air within the pleural cavity, so the space between the musculature and the lungs themselves. So between the visceral and parietal pleura, we have this intrapleural pressure, the pleural cavity. Similar to the intraalveolar pressure, the intrapleural pressure also changes during the different phases of breathing. However, due to certain characteristics of the lungs, the intrapleural pressure will always be lower or negative to the intraalveolar pressure and therefore the atmospheric pressure. So the intrapleural pressure will always be negative compared to these two. So pulmonary ventilation comprises of 2 major steps: inspiration and expiration. Inspiration is the process that causes air to enter the lungs. Expiration is the process that causes air to leave the lungs. In general, 2 muscle groups are used during normal inspiration: the diaphragm and the external intercostal muscles. Additional muscles can be used if a bigger breath is required, but in general, we'll just talk about these 2 muscles. When the diaphragm contracts, it moves down toward the abdominal cavity. This creates a larger thoracic cavity, the space that the lungs are in. So that creates a larger thoracic cavity and more space for the lungs to move. So contraction of the external intercostal muscles will move the ribs outward. So it kind of looks up going this way, but think of it as like a balloon expanding, and the outside of the balloon is expanding. So those ribs are literally moving outward, causing the rib cage to expand, which also increases the volume of the thoracic cavity. And due to the adhesive force of the pleural fluid, that fluid in between the parietal and visceral layers, or pleura, visceral and parietal pleura. So this adhesive force of this pleural fluid that we talked about, the expansion of the thoracic cavity forces the lungs to stretch and expand as well. So because that pleural fluid is adhesive, it pulls the lungs to stretch and expand as well. And this increase in volume inside the lungs to a decrease, or this increase in volume leads to a decrease in intraalveolar pressure. So there's more volume to operate in there now, and so now there's less pressure in there as well. And this creates pressure lower than the atmospheric pressure, which brings air in to the lungs. Intrapulmonary pressure is less than atmospheric pressure. The air is going to travel down its gradient, down its pressure gradient. There's more pressure outside than in, so it's going to move the air in. And as a result, a pressure gradient is what creates the driving air into the lungs. So this changing volume leads to the changing pressure within this cavity. Gas movement occurs. And then all that happens for expiration to occur is relaxation. So the diaphragm and the external intercostals relax. Passively, air just moves back out, down its concentration gradient, since the pressure has changed once again in here, but now it's opposite. The pressure is higher inside the lungs than outside, so the air is able to move out. Totally passive process. No energy is required for expiration. So let's sum it up in 2 different slides just to make sure we're all on the same page. So, inspiration now. The thoracic cavity volume increases via skeletal muscle contractions, so the diaphragm and external intercostal muscles. So, to start off, the pressure of the alveolar the alveoli is less than, or it's equal to the pressure of the atmosphere. So they're equivalent to each other. So there's no movement. They're equal. Well, once the skeletal muscle contraction occurs, the intrapulmonary pressure is going to decrease. And that happens because the volume in there increased. And so that's what we're seeing here. Our volume, look, this is bigger than this. Our volume increased, which means our pressure decreased. The pressure is now less than the atmospheric pressure, which means the air is going to move down its concentration gradient or down its pressure gradient and into the lungs. So we can equalize that. So the air is moving into the lungs during inspiration, down its pressure gradient based on volume increases and pressure decreases inside the lungs. Why is energy required here? Because you have to contract those muscles and use energy to use those muscles. So the diaphragm and the external intercostal muscles have to be used. We have to use ATP for those contractions of the muscles. And then energy is utilized to create all of this. Well, now we have air in the lungs. We don't need it in there constantly. We got to get it out. And so the thoracic cavity volume decreases because of relaxation. So these muscles relax. They're not using any energy. Well, since the volume decreases, our pressure increases. So now our pressure is higher than the atmospheric pressure. So our alveolar or intrapulmonary pressure inside the lungs is higher than outside, so that air has to move out of the lungs. And the air flows out of the lungs based off its pressure gradient. Once again, it's the same thing as inspiration, just the opposite way. It's all based on pressure. And this is passive. No energy is required because we're not contracting anything, we're relaxing our muscles. So once again, I have a nice little video just in case I was not clear enough, or if you'd like a different perspective. This is Dr. Mike again, explaining simple breathing just like I did. It's an awesome watch. It's about 5 or 6 minutes long. I highly recommend you use it, and I'll make sure I leave it in here so that you guys can click to that for extra studying.